Birds occupy every corner of the world, even in the most desolate locations like Antarctica and the Sahara Desert. But have you ever wondered about the origins of these creatures? Obviously, birds are dinosaurs and are the only surviving lineage of the Dinosauria and the Avametatarsalia in general. But what was the first bird? Where was the point that dinosaurs became these creatures that roamed the sky and even survived the death of 70% of species when the pterosaurs failed to? You might have a good guess as to what and when this was. Hundreds of years ago, in 1860, a single feather was unearthed in the Solnhofen limestone formation in Bavaria, Germany. At first, this fossil was thought to have been from the Pleistocene, which was the first epoch of the Quaternary period, lasting from 2.6 million years ago into 11,700 years ago. But the specimen was later found out to have lived during the late Jurassic, around 150 million years ago. With the fossil being only a feather, there weren't enough remains to name a whole species, but rules like that had not been set in place yet, and it was named Archaeopteryx lithographica. Archaeopteryx means ancient wing. The second fossil was found the same year it was described, in 1861. This specimen has been found from the same limestone deposits as the holotype, but this time they discovered a complete skeleton. This revealed something rather shocking. It looked like a bird. This new creature that they had discovered seemed like it was the first bird, but after further inspection, they found out that this was more like a non-avian dinosaur than a bird. It had sharp teeth, no beak, and its feathering was different from modern-day birds. After its analysis, they proposed the Archaeopteryx to be a transitional fossil between non-avian dinosaurs and the modern-day birds. As the years went by, they uncovered more and more specimens in the Solnhofen limestone formation, and to date, there have been a total of 12 specimens discovered. After looking at all of the specimens, they actually found out that 2 of them had not been the Archaeopteryx, but 2 other genera. These were the Wonhoferia grandis and the Gyrapteryx recurvae, 2 other likely avians at the time. Ever since the discovery of Archaeopteryx lithographica, 2 more valid species have been described, the Archaeopteryx siamensii and the Archaeopteryx bavarica. In recent years, the validity of the holotype Archaeopteryx specimen has dwindled, as in 2019, a paper was published stating that the first specimen was not the Archaeopteryx they knew from the rest of the discoveries. It said that the quill structure on the wing was inconsistent with other fossilized feathers found. While this evidence was true, the original feather was found to have been a different feather, called a covert feather, which is the real reason why the quill structure was different. A covert feather is a feather that lies on top of the others and aids in gliding and helping with the airflow over its wings and tail. The Archaeopteryx, along with some dromaeosaurids, was a dinosaur with the ability to glide. But could it fly? This question has been perplexing paleontologists for decades upon decades, but we might have an answer. The 2 main flying creatures alive today, birds and bats, have many different styles of flying. Some move their wings extremely fast, like bats or swallows. The Archaeopteryx probably would not have been able to do this, because its shoulder and wrist bones were too weak. There was also another style used by the Accipitriformes, soaring. This is when a bird's broad wings make it so that they don't have to flap as hard or as fast. They also use thermal air vents to circle around and lift them further up into the sky. The Archaeopteryx's broad wings make it apparent that the Archaeopteryx could almost definitely have used this flying method. Another controversial aspect of the Archaeopteryx was its colors. You might be wondering how we'd tell what color a dinosaur was, because color doesn't fossilize, obviously. We use something that does fossilize, melanosomes. Melanosomes are structures that lie within feathers and skin that, depending on the shape, decide what the color of an animal is. An example would be that rod-shaped melanosomes typically indicate a darker maroonish color. The Archaeopteryx seemed to have a blacker color at first, but later was revised to have been white and black colored. This research was done a while ago, though, when we didn't have as good tools to do these types of analysis. And after further research, it was most likely to have been completely or mostly black. The environment that the Archaeopteryx lived in was ideal for its lifestyle. Its diet consisted mainly of insects, small amphibians, and small reptiles. The tropical archipelago that Europe used to be housed a dense rainforest, a perfect environment for its prey. The Archaeopteryx could have used its ability to glide and possibly fly from tree to tree. In recent years, the Archaeopteryx's classification has come into question. Just so you understand the Deinonychosauria phylogeny, the Deinonychosauria is a group that contains the Dromaeosauridae, the Troodontidae, and the Avialae. For the longest time, it had been described as an early avialan, but recently it's been said that the Archaeopteryx diverged before the avialans. The Archaeopteryx is currently in its own group, Anchiornidae, within the Deinonychosauria, alongside others like the Anchiornis. The Archaeopteryx isn't likely the first bird, but this new classification uncovers a whole new amazing theory. The Anchiornids most likely evolved to fly independently from birds because the Deinonychosauria's last common ancestor most likely could not fly. No matter what Archaeopteryx is, it's a truly remarkable creature. It was the first feathered dinosaur discovered, one of the first pieces of evidence of melanosomes fossilizing, as well as inspiring many more studies that further our understanding of dinosaurs in general. When this creature was around, the world was entirely different, and the Archaeopteryx was an integral part of a massive thriving ecosystem, only being wiped out by the passage of time.